Okay, so the first thing that you want to know is the fact that there are 20 questions on your test. Okay, there's AKS 20. Okay, which there are 3 questions on that. There is AKS 31, 35, 38, 47, 49, and 50. And there are 14 questions on that. And there's AKS 60, and there are 3 questions on that. Okay, so whenever we create these interim reviews, we're basing it off of this knowledge. Okay, so I just need you to know that when we're having stuff like this section, this could be anything. This could be word problems, this could be an equation, this could be a graph, okay, because this covers key features, inverse functions, the whole shebang. Okay, so this is what we see as teachers. Okay, now there's going to be 20 multiple choice / inline response. So basically what inline response means is you'll have like a drop down option and you'll pick one of those options. It's basically multiple choice. It's just a different way to click it. Okay. So on your interim review, the first thing that you're going to do is questions 1 through 4, which you're going to plug into your graphing calculator, and you're going to find the domain and range. Okay. The best way that I do this is I say, what is my farthest left X value? So my right X value, and that's my domain. And then I say for my range, what's my lowest Y to my highest Y? Okay, that's what I always ask myself. Okay, so we're gonna go over the first question on the review guide. If I can find it. There we go. Okay, so we've got this. We've got 5 plus the square root of X plus 2. Okay, so 5 plus the square root of X plus 2. Okay, so what we're going to do is we're going to go into Desmos. That'll be the first thing that you do. Go into Desmos, and you're going to type it into Desmos. So we'll say 5 plus the square root of X plus 2. Okay. So when we do that, what we get is this little line right here. Okay. So for my domain, what's my farthest left X value? -2. Okay, so -2, and that's going to be included. So I'm going to use a bracket. Okay, if it's not included, we're going to use a parentheses. So how far right does it go? Infinity. Okay, for my range, I'm going to say, what's my lowest Y value? 5. What's my highest Y value? Infinity. Okay, are there any questions on that? Okay. Now, when I ask for you to do just like a little sketch, all I'm asking you to do is just kind of give me the shape of the graph. Okay, so that's all I'm asking you for. So when you do the shape of the graph, you're going to go from here, and then you're going to go to the right. Okay. Now, let's say that it's a word problem, and we're dealing with something in context. Okay. I'm going to show you in context problem. Let's say I have something like 2 raised to the X. Okay. And I say that this is a bacteria population. And I say this happened over 3 days. Okay. And I'm asking you for the domain and the range. Okay. So when you're dealing with a bacteria population or you're dealing with a word problem, you're normally going to cut off your negatives. Okay. You're not going to deal with a negative day. Okay. Because your x-axis is going to be the time or number of days. And your y value is going to be the number of bacteria. Okay. So what's my initial bacteria? What's my initial bacteria? 1. Okay, so that's going to be my range, my lowest y value. Okay. For domain, what's my farthest left x value? 0. And then what's my farthest right x value? Don't say infinity. Not 5. Well, remember how I told you that this goes over for 3 days? So it's going to be from 0 to 3. Okay, so you've got to make sure that you're actually reading the problem. Okay, because sometimes they give you that instruction. Okay, sometimes they'll just give you a graph, a picture of a graph, and they'll say from 0 to 4, because that's the only thing that you can see from that graph. Okay, so you just kind of have to be careful, and each word problem is a little different. Now for my range, I told you my lowest y value is 1, because that's my initial population. What's my highest y value? It's my highest y value. Well, let's think about it. This happens over 3 days, right? Okay, so if I take 2 to the x and I plug in that 3 for x, that's going to give me my y value on day 3. So this will be from 1 to 8. Okay, a lot of us missed this on the quiz because we didn't read the instructions up at the top. Okay, if it's a word problem and it's in context, normally it's going to have set numbers. It's normally not going to be infinity. Okay, keep that in mind. You have to read. There's going to be word problems. There's 20 questions on this test. It's going to have a word problem. Okay, are there any questions on domain and range? Okay. All right, so going back to our little cheat sheet. Okay, and even if you need a little bit more practice, there's a YouTube video right there from previous years, so you can totally look at that as well. On numbers 5 through 8, you're going to get the radical alone, square both sides, and then check for extraneous solutions. Extraneous solutions means that it doesn't work. Extraneous solutions means it doesn't work after you plug back in. Okay, so like you solve for something, you plug it back in, it doesn't equal both sides. Okay, so let's do an example problem of that. If we go to, I'm going to do number 6. Okay, so on number 6, we're going to isolate a radical first. So we've got -6 equals -7 plus the square root, and y'all can't see that. Here, one second. -6 equals -7 plus the square root of 3 minus x. Okay, so I'm going to add 7 to the other side. That's going to give me 1 equals the square root of -3 minus x. Now I want to get rid of that radical. So the only way to get rid of it is to square both sides. So 1 squared is 1. The square root of something squared is whatever's on the inside. I still want x by itself, so I'm going to add 3 to the other side. So 1 plus 3 is 4. And I still want x by itself, so I'm going to divide by -1. And so x is going to equal -4. With radicals, you have to plug back in. So you've got to check it in order to make sure it's right. Okay, so I'm going to plug back into my original equation. And when I simplify, it's going to give me -7 plus the square root of 1. So -7 plus 1, which is -6. And that equals both sides. So x equals -4 is in fact my answer. Okay, so on number 8, we've got x equals the square root of 42 minus x. So we want the square root to be on its own, right? Which it already is. So in order to get rid of that square root, we're going to square both sides. And so this will be x squared equals 42 minus x. And now I'm going to move everything to the other side because it's a quadratic. So I've got x squared plus x minus 42 equals 0. And now I'm going to factor because it's a quadratic. Okay, so I'll do the big X. 1 times negative 42 is negative 42. B is 1. What two numbers will make that happen? 7 and negative 6. So this could be x plus 7 times x minus 6. If I solve for that, that's going to give me x equals negative 7 and positive 6. And now I'm going to plug back into the original equation to check my work. Okay. I'm just going to let you in on a little secret. If there's a negative in your answer and you plug this in, negative 7 equals a positive square root, that can never happen. So I automatically, without even simplifying, know this is wrong. Yeah. It means that there's an x squared. Yes, and you're going to have two solutions probably down here. Potentially two solutions. Yeah, babe? Right, so we wouldn't include that in our answer. Okay, if we take 6 and we plug it back in here, we get 6 equals the square root of 42 minus 6. 42 minus 6 is the square root of 36. What's square root of 36? 6. Is 6 equal to 6? Yeah. So what your final answer would be is x equals 6. Now, I'm going to be perfectly honest with you. If they give you one of these questions, take your answers and plug it into the original equation. Don't even try to solve it. Just plug it back in. Okay. So for instance, if they gave you answer choices like 6, negative 7 and 6, and 12, negative 7, I would plug these into this original and see which ones work. Make sure you check all of them because it could have two answers. Okay. Yeah, babe. Then it's going to be wrong. So for instance, like if this was an answer choice, this would be wrong. This would be wrong. You can narrow it down. Yeah. Yeah, babe. Yeah, go ahead. All right. The next one. Okay. So we struggle a lot with these. So really quick, if I had x to the m over n, okay, how I would write that out in radical form is I would say the nth root of x to the m power. Okay. So what goes in the denominator? So the denominator is going in that little cubby hole. Okay. So the denominator is going to be in this little cubby hole. Okay. So let's look at 9 through 16. Okay. So on 9, yeah, let's do 9. If I have this, I'm going to write it in exponential form. So I'm going from this one to this one. Okay. So that means x to the 2, because right here, that exponent, over 3, which is in that little cubby hole. If you can simplify that fraction, do it. Okay. On the next one, I've got a 2 right here. Remember, if there's nothing written there, you assume it's a 2. So I've got 3n raised to the, notice how I put parentheses around it, 5 over 2. Make sure you use those parentheses. It's because it's inside of this radical, and these parentheses right here are telling you to raise what's in that radical to the 5th power. Let's say that it was written like this, the square root of 3 into the 5th. Then that would just mean that n is to the 5th power. So why did you put 5? So this only has one variable, right? Since there's 2 variables here, they had to use those parentheses. Okay, so let's scroll down just a little bit. Let's do number 15. Let's do number 15. Okay, sorry I'm jumping around. I'm just trying to hit the highlights. Okay. On number 15, you've got 2b raised to the 5/3. You're trying to go from this one to this one. Okay, so 2b is going to go in the little radical. The denominator is going to go in this little cubby hole. And the exponent is going to go inside here. Remember to use your parentheses. Okay, if this can be simplified, you're going to do it. Okay, so for instance, this is saying that you have 5 2b's. And you want to make a group of 3. So how many groups can you make? Well, 1. So I'm going to pull out a 2b outside. And how many am I left with? 2. Well, what's 2 squared? 4. What's v squared? V squared. So my final answer would look like this. Got it. Simplifying. So we have 5 of the 2b's, right? We wrote them all out. We want to make a group of 3. So we make a group of 3. How many groups do we have? 1. How many are we left with? 2. So I've got 2v squared on the outside, inside, 1 group of 2b on the outside. That's how I would write it. Okay. Let's talk through 16 really quick. So we've got 6m. We're going to do the cubic root, and we're raising it to the 5th power. So same thing that we did on the last one. We've got 5 6m's. We're going to make a group of 3. So we pull 1 out. How many are we left with? 2. Well, 6 squared is 36, and m squared is just m squared. So I have 6m cubic root of 36 m squared. Yep. So I did 3 because it was what was in this little cubby hole. Yeah, because it came from that denominator. Questions on this one? Which one, on the 15? On this one? It's on this little, like a little bracket. On the inside, 36. 6 squared is 36. I was like, what 3? Okay, and just to kind of reiterate, I did include this interim cheat sheet on your e-class page. So if you want to just like look through it, you can. Those YouTube videos are also posted on there, so you can revisit those. Okay. Yep. Because that's in the denominator for this exponent. So that's what root you're taking. Yep, it'll be 3. Yep. Okay. Come back over here, looking at questions 17 through 22. Simplify using your exponent rules. Guys, you have to have these exponent rules memorized. If you don't, you've got some work to do. There's a lot of Khan Academy and quizzes and Kahoots that practice these. So if you need some practice, just Google it. Exponent rules, quiz, and you can kind of practice. Okay. One thing that I always used to do in high school, whenever I didn't have these memorized, if I have 2 to the 3rd and I'm multiplying it by 2 to the second. Well, this means I have 3 2's, and this means I have 2 2's. Okay, how many 2's do I have in total? 5. Okay, so that means that I'm adding my exponents. Okay, if I forget the quotient rule, I would have 2 to the third divided by 2 to the second. That means I have 3 2's and 2 2's. They cancel. How many do I have left over? 1. So that means I'm subtracting these. Okay, so even if you don't have them memorized, plug in numbers and see how that rule actually works. Does that make sense? Okay. You need to know the 0 rule though. This is one you need to know. Anything raised to the 0 power is 1. There will be a question on there. Okay. They try to get you with that every single time. Okay. Know your negative exponent. If I have a negative exponent, then that means that the fraction that I have, I'm going to flip. Okay. So if I have a -1, I'm going to flip it. Okay. What if I had 4 to the -3rd power? That would be 1 over 4 to the 3rd power. Okay. We good on those. Okay. So simplifying using those exponent rules, definitely important. Let's go to question number, I'm trying to remember what I did in the last class. Let's do 17. Does that help? Okay. So 17, what you're going to do is you've got the 6th root of 128 b to the 2nd power. So let's look at our variable first. Well, we have b to the 2nd power. That means we have 2 b's. Okay. And we've got a little 6 in this cubby hole. Can we make a group of 6? No. So that guy's going to just be left underneath b to the 2nd. Okay. It's kind of like getting in an Uber. If you don't have enough to go on into the Uber, you can't leave, right? So you have to stay inside the little radical. Okay. This 128, if I take 128 and I plug it into my calculator, I go in here and I say 128 raised to the 1/6 power, because that's the same thing as taking the 6th root. That gives me a decimal. So I know that it's not going to be a whole number. Okay. Now, my favorite thing to do is take an even number and divide it by 2 to see if I can pull out any factors. Okay, so watch what I mean by this. If I take 128 and I divide it by 2, that's going to give me 64. If I divide again, I'm going to get 32. If I divide again, I'm going to get 16. If I divide again, I'm going to get 8 and 4 and 2 and 2 and 2. Now I want to make a group of 6. Well, there's 1, 2, 3, 4, 5, 6 2's. How many groups of 2's do I have? 1. So I can pull 1 out. And how many am I left over with? A 2. So I'm going to leave him inside here. Okay. If you don't like doing this, okay, because I'm going to be honest, I don't like doing it either. What I can do is I can take my answer choices and plug it into my calculator. Okay. So what I mean by that is, you see how this is the 6th root of 128? Well, I already have that decimal form over here in my Desmos. Well, if I take my answer choice of 2 6th root of 2, if I come in here and I say 2 6th root of 2, notice how they have the same decimal points. They're the exact same answers. I didn't have to do any math. Okay. Use your calculator. It's cheat codes for a reason. You can use Desmos. And there's also a TI-83 calculator. So it's just like the one that you get here. I'm not sure if you know how we can do logs with math window 5. I don't know if you can do that on there. So just keep that in mind. Now, I don't think there's going to be a whole lot of logs on there. If there is, it's just going to be a graphing thing. But I wouldn't fret about that. Yep. Yeah. All right, let's do 19. Okay. I'll show you that one in a second. All right, so let's do 19. Okay, so I have the square root of 48 into the fourth. Okay, so I have, let's do our variable first. I have 4 ins. I'm making a group of 2. I can make 2 groups, right? So that means I'm going to pull out an n to the second power. Now, when I take the square root of 48, I get a decimal, right? But that's an even number. So what I can do is I can divide it by 2 and see if I can break it down into anything. So if I have 48 and I divide by 2, I get 24. If I divide by 2 again, I get 12. If I divide by 2 again, I get 6. I can get all the way down to 2 times 3, right? Well, how many groups can I make? Well, there's 2 2s here and there's 2 2s here. So I can pull out 2 to the second power. I'm sorry. This is a 2 right here. And this is a 3.
Can you run it next to the blue on the bottom?
Oh, 2 to the second power. Sorry. I didn't know y'all can see that. 2 to the second power. I'm going to write this a little bit over. So this will give us 2 to the second into the second. And we're taking the square root. Okay. Now, what am I left with in this little tree? I'm left with a 3. So that 3 is going to stay inside the radical. Okay. Can we simplify 2 to the second? Yeah. That would give me 4 to the n to the second square root of 3. Okay. Like I said, I would really take the square root of 48 and then I would look at my answer choices and see which one gives me the same. Okay. All right, let's go through 21. Everybody freaks out about this one. Okay, so on 21, a whole hot mess. Okay, so on 21, what you're gonna do is you've got 1 million into the 12th power raised to the 5/6. Okay, so we're gonna take the 6th root of 1 million into the 12th, and we're raising all of that to the 5th power. Okay, so let's look at our variables first. If I have a 12 raised to the 5th power, that means that this is going to be into the 60, because you're going to multiply 12 times 5. Now, I'm taking the 6th root of that. So how many groups can I make? What's 60 divided by 6? 10. So I have into the 10th power that's going to be on the outside, with none left over. Now, I have 1 million raised to the 5th power. That's a lot of zeros. Okay. Is there any way to have the exponent written in terms of base 10? So if I raise 10, to what power would I get a million? 6, right? So let's rewrite 1 million as 10 to the 6th, and we're going to raise that to the 5th power. So what am I going to do with my exponents? So 6 times 5 is going to give me 30. Well, take 30 divided by 6. What is that going to give you? 5. So this is going to be 10 to the 5th power, with nothing left over on the inside. Okay, so let's write out our final answer. That'll be 100,000 into the 10th power. okay? The reason why I changed 1 million to base 10 is because I saw that there's 6 zeros. And I saw that I was trying to make a group of 6. So I rewrote it in terms of 10 to the 6th power, just to make it a little bit easier to deal with. Okay, because if you take 1 million and raise it to the 5th power, you're going to be sitting there writing 30 zeros. Okay. Questions on this? Okay. Is this helping anybody? Okay, cool. All right. I always just want to check, make sure. Okay, the next part, graphing radical functions. Okay, you need to know your transformations. Again, there's a YouTube video on this, but you need to know what K does to the equation, what H does to the equation, etc. Okay, so on 23 through 26, you're just graphing, but what I really need you to get from that is the transformations. Okay, and Desmos definitely helps you with this one. Okay, so let's do 23. And y'all are pretty good about these. You might mix up a couple of things. So I would take this equation and I would go straight into Desmos. Okay, so we got 1/2 multiplied by 4 raised to the x plus 1. Notice how I use parentheses around it. Okay, if you don't, you're going to change your graph. Okay, and we're comparing that to the parent function, which is going to be 4 to the x. Okay, so 4 to the x is going to be in the blue, and then 1/2 our function is in the red. Okay, the 4x is like the parent function. Like if you stripped all of that down, it would be 4x. Yeah. Okay, so what happened between 4x to this crazy equation up here at the top? Tell me the transformations. Say it again. Asymptote did change. What did it do? Okay, so move down 2. And it has a horizontal asymptote at -2. Okay, what else we got? And honestly, best way to do this is to take off the things that you list for the transformations. So that way you can kind of see what happened. So what did that x plus 1 kind of do to the equation? From blue to red. From blue to red, where did it move? To the left, how many? 1. Okay, left 1. And we can see that from our equation up here. Okay, so let's say that we take that part off. Okay, now from the blue to the red, what did we do? This one's a little bit harder to see. That 1/2 shrinks or compresses the actual function vertically. So compress vertically. They're also going to use a term called shrink. You'll see that sometimes as well. By 1/2. Okay. So when you're graphing those equations, I really want you to make a connection between the transformations. Okay. Writing the equation. You're not actually going to be asked to write the equation. What you'll be given is you'll be given the graph, and then they'll say, what is the equation? And then they'll give you multiple choice options. So what do you think you're going to do? Plug it into your graphing calculator, graph all those bad boys, and then pick the correct one, right? Okay, but let's say that you actually did have to write an equation for this. The first thing that you'll notice is this is exponential. So that means it's going to be y equals a times b to the x, where a is your y-intercept and b is your rate. Okay, so what's my y-intercept on this guy? 3. Okay, so 3 is going to go out here. And then from 0 to 3 to the next point, which is 1 comma 6. If we took 3 and multiplied it by a number to get 6, what number would that be? 2. So 2 is going to go in for B, and we're going to raise it to the x. Okay. On 28, you're going to notice that it shifted to the right a little bit. Okay, so when you're writing out your equation, there might be some number added or subtracted up here. Okay. So for this one, we notice how it kind of moved to the right, right? So it moved to the right. So that means that you're going to say x minus some number. It's going to be 1. So when you're solving for this one, okay? And you can always check your work by plugging it in Desmos, right? So if I think this is the equation, I would go into Desmos, plug it in, make sure it matches up, okay? 3, 2 to the x.
Oh, so you don't have to put a number here. You put it in the x, so it comes out that if it's right, it will come out.
Yep. 2 I got from taking my y values. I went from 3, which is this 0, 3, which is this first point, to 1, 6, which is the next point. From 3 to 6, I multiplied by 2. And I can look at the next point as well, which would be 2 comma 12. From 6 to 12, I multiplied by 2. Yeah. Say again.
3 is on the outside, so that's the initial.
Yep, 3 is on the outside because it's our initial value. All right. All right, exponential interest problems. Okay, I think I want to correct myself. I think I don't know if it was somebody in this class or not. I made a boo-boo error on one of these problems. You do need to know this one pretty well, and maybe this one. I don't think that you're actually going to have to like plug in or create an equation or anything like that. I do think you're going to get like a graph, and they're going to ask you about like key features, like, you know, what was your initial starting point? What is your expected amount after a certain number of years? Okay, so they'll just ask you like questions like that. So let me go over the one problem that I know I made a mistake on with somebody. I apologize. I'm gonna blame it on, it wasn't my fault, but it was my bad. Okay, I can't be perfect all the time. Number 32. So a company promises to release a new smartphone model every month. Each model's battery life will be 5% longer than the previous models. If the current model's battery life is 736 minutes, what will be the latest model's battery life between 7 months from now? Okay, so I'm going to use the a times 1 plus r raised to the t. Okay, and you're actually going to use that for all 4 of these. Fun fact. Okay, your initial amount is 736. That's coming from here. You're going to multiply it times 1 plus, my rate is 5%. Please remember to change it to a decimal. Okay, and they're asking for 7 months. So you're going to raise this to the 7th power. And you're going to take that and you're going to plug it into your calculator. Okay, and it's like something like 1,000 something. I don't know off the top of my head. Yep. Yes. Yeah. You can go ahead and add those together. Yeah, T is 7. Can somebody tell me what that answer is? It's like point what? Good. And just remember, this is in minutes. I was gonna say dollars. It's not in dollars. It's in minutes. Boom. Okay. Question. Okay. Yes, we love it. Inverse functions. I think this is the last one that we got to go over. Inverse functions, you're going to switch your x and your y. You're going to solve for your y. I was tutoring my little sister last night on this. plug in your original equation and then plug in the other equation as the option, and you should see the reflection over across the line y equals x. Let me do one really fast. This one, for instance. Oh, we won't have enough time for that. Okay, if you need help on this, remember you can come at 7 p.m. The other thing is in behavior. I love you guys, but y'all suck it in behavior. Okay, as x is going to negative infinity, what's happening to your y values? You're literally look at what's happening to the left, what's happening to the right. Okay. All right. Reminder, please get your interim review done. It is due. It is for a grade. If you need this cheat sheet, it is on eClass in PDF form. And then there's all those YouTube videos that are embedded. Utilize that stuff, people. I want you to do well. Y'all good luck.